I am Ekre, a rocketeer. Today I interview a DanSTAR rocketry team from the Technical University of Denmark, which will compete for the 9-kilometer liquid rocket competition at EuRoC.
DanSTAR, or Danish Student Association for Rocketry, is currently the only student organization in Denmark developing rockets. Founded in 2016 at the Technical University of Denmark, DanSTAR currently engages 44 students originating from 11 different countries and studying a variety of engineering educations. Structurally, DanSTAR is split into 4 different primary teams, each team focusing on developing and building their respective parts of our projects. At EuRoC 2020, DanSTAR became the first European student team ever to launch a bi-liquid rocket. This was done using our very first rocket, Dragonfly, a fully liquid-fueled rocket made from the ground up by DanSTAR that after launch reached an altitude of 2.2 kilometers. Following the successful launch of Dragonfly, DanSTAR announced Project Valkyrie in January 2021. The aim of Project Valkyrie is to beat the world record for highest altitude reached by a student-built bi-liquid rocket. With an altitude to beat of 6.7 kilometers and only 10 months to develop the rocket, our new project relies heavily on our experience from Dragonfly. While in many ways identical, several improvements have been made to the old design, increasing efficiency and raising the theoretical altitude to more than 7.5 kilometers. With a brand new engine and custom-made flight computer, rigorous testing of the new rocket systems has been performed. Confirming the proper functionality and showcasing the awesome power of the known child engine, Valkyrie is closer than ever to being ready for launch.
Could you please introduce yourself?
I'm Amalie. I am the chairman of DanSTAR and also the mechanical team lead. So what I do is I structure the time schedule, basically. I do a lot of fundraising. Rockets are expensive. And I keep track of all the physical work we do on the rocket itself. So, the engine, where everything goes, basically.
I'm Sarah. I'm the vice chairman, and I'm also part of the software team. And I also help Amalie with all this, keeping track of how everything is going, how everything goes, and have an overview of the whole team.
We have Dragonfly in the background here. We thought that was way better than some boring meeting room.
Yeah.
How do you think that someone could start a rocketry team without an aerospace faculty?
So we actually don't have an aerospace faculty at our university. We do have DTU Space, but they're a lot more directed towards satellites, things that are already in space and not on the way to space. So obviously, DanSTAR managed to start a rocketry team with this situation. And we think it requires just a lot of passion, a lot of grit, hard work. I think that's a pretty common denominator for all students interested in rocketry. We all tend to be very passionate about what we do.
Can you study all in English? And how did you study in your university?
Some study lines at our university that are only in English. On the bachelor level, we only have 1 or 2 study lines that are only in English, but all of our master's programs are entirely in English. So anyone can do a master's program at our university in Denmark and understand, hopefully, everything going on. We can't, vouch for the technical understanding, but at least the language will be the same.
What are the job opportunities after your university?
We have a lot of members that are working on space related, but mostly it's startups, right?
Non-Danish companies. It is an opportunity. There are opportunities in Denmark to work within the space sector, but upstream space is quite difficult to do in Denmark at the moment. We don't have any launch facilities per se. So a lot of our members have found jobs within the space sector, but it's in non-Danish companies, and we don't really have any upstream space industry in Denmark. We don't have any launch facilities. So, that part, which is primarily what we do in DanSTAR, build rockets, build launchers, that's going to be quite difficult to do in Denmark at least. But luckily, Europe is quite well connected. So I think there are multiple opportunities, to go anywhere else in Europe.
How did you prepare for university?
I come from electrical engineering, so it's not related to rockets. So I didn't have any preparation when I came here, and I saw DanSTAR building their rocket. So I didn't have any rocketry preparation or anything. I don't know if you had.
No, I mean, it's not really a common hobby to build bi-liquid rockets, from a young age. But at least personally, I've always had the interest in all things rockets and, the space industry in general. I don't know if you had that interest from childhood as well.
Yes. Yeah. I've always been passionate about space. And yeah, I mean, I think I started to get a little more involved with rocketry when I saw SpaceX, obviously. So yeah.
Elon Musk effect.
Yeah.
Yeah. I think I got really interested in rocketry and, space in general when I realized that the moon looked differently from, different points on the Earth. So I lived for a few years in Dubai, where the moon looks different from how it does in Denmark. So I thought that was really cool. As a kid, I was like, I gotta check that out.
What are your team's goals and plans?
I think every, university rocketry team or just any, collegiate rocketry team on the planet wants to go to space. Like, why else would you want to build rockets?
That's the dream.
That's the dream. Yeah. Someday we're gonna build one that can contain a man, probably, or person. Sorry. But yeah, I think we're all dreaming about going to space with a rocket that we build ourselves. Obviously, that's quite a distance in the future for us. We are only building our third and fourth rocket at the moment, and we've only existed since 2016. We were founded in 2016, and we launched our first rocket in 2020. So, the high activity level has only been, for a short amount of years. So we're not expecting to reach space, within the next few years, at least not in my time in DanSTAR. I'll look forward to seeing it happen afterwards. But yeah, I mean, obviously, I think space is the overarching goal for everyone. And we obviously have, smaller goals until then. Last year, our goal was to beat the world record for, highest apogee reached with a student-built bi-liquid rocket, and we achieved that. So, this year, our goal is to recover our rocket successfully in one piece.
Yes.
And with only minor scratches, hopefully.
Fingers crossed.
Fingers crossed. We're working hard on that at the moment. So yeah, we have lots of goals, and I think it's important for us to, cut up all our major goals into smaller and more obtainable ones. Otherwise, you're just going to break your neck thinking, we have to go to space, and trying to get there in one project is going to be a struggle, I think.
How do you recruit people into your team?
We actually have a specific recruitment period. Yeah.
I mean, it's not hard for us to find people for our team. I mean, everyone is very interested in rocketry, and I think what we do is very, very special. And but yeah, this year we had just a recruitment period, so everything is it's easier for us to get everyone at once and not in different stages of our development, of our project development. And yeah, I mean, you were involved. Yeah, you did it. So
twice. Yeah, no, it's not hard finding people that are interested in rockets, but it can be a little difficult finding people that are willing to make the necessary sacrifices to build these rockets, at least with the time pressure that we have at the same time. We all want to make it to EuRoC every October. And that puts a very specific time limit on the projects. So on introducing someone new every week or every other week is not very efficient. And we found out it was way more efficient to have these 3-week periods where we welcomed all the recruits, everyone that were interested in joining, and we gave them some recruitment projects. So some projects that were a little more manageable than, build a world record breaking rocket as the first thing you do in this new team.
Yes.
So people had an easier start in the team. And it was also easier in terms of, aligning the expectations a little bit. So, we could get everyone on the same page from day one, basically. They've all heard the same information. They've gotten the same introduction speeches about, what's important. So that was, very successful for us. I think we're going to continue doing these recruitment periods.
How do you manage new team members?
So we don't scare people off by immediately giving them a task like, you can design the next engine, or, design the new flight computer or something similar, but that they get, smaller tasks that are an entry-level task, basically.
Yes.
Yeah. while they're still getting adjusted to the workload, because we also do require, quite a few hours every week from our members. We usually have a rule of thumb that says that you should be able to spend a day every week on
At least
a day.
Yeah.
For some, it's a little more than a day. But yeah, so we do try to inform people that we do expect quite a lot, and people also get the opportunity during this recruitment period to both opt out and say, this is just not for me, whether it being because of the work that we do or the workload or whatever it might be. Or, they might just find out that the expectations that we raise will not align with, how they want to.
How do you manage your team?
We have 4 different teams. We have mechanical, software, electronics, and marketing. And within those teams, we have sub-teams to kind of structure our work. So, for example, under the mechanical team, we have propulsion and structures, etc. Under software, we have embedded and mission control. So just kind of to, split up the team a little bit more, just to be more transparent with what we do. So when new students want to join, for example, they have a clear idea of, what different types of work they can actually do in our team. Because we actually got some criticism, or not criticism, but some confused comments a while ago before we, highlighted these sub-teams, that some chemists came by and they were like, I'm really sad that I can't do anything for this team because rockets sound so cool and I'm really interested. And like half of our rocket is chemistry, because we built by liquid rockets, which is basically chemistry. And they're like, I'm so sad I can't join. So we had to kind of emphasize that the different, technical backgrounds that we actually require in the team, because we do need chemists. And it's a shame if we don't really advertise to them that we need them. So we're highlighting this a little bit more.
What's the experimental rocketry community in your country?
We are basically 2 teams in Denmark. Yeah. No, actually, we're 3 teams now.
We are 3 teams.
Yeah. So, DanSTAR, of course, that's us. And then there's Copenhagen Suborbitals. They're not a student team, but a group of real adults, as we call them, but still volunteers. And their project or their goal is to send a man to space on a budget, which is really cool. There's quite a few videos about them on YouTube as well, made by other people interviewing them or other documentarists. So that's really cool. And then recently, a new collegiate rocketry team has started on ELS, I think. That. Yeah. So hopefully we'll see them at EuRoC. We'll get some competition on the Danish experimental rocketry in universities fairly soon, hopefully. We're rooting for them. It would be great to have more people to collaborate with in our own country. Even though the collegiate rocketry community is not very big in Denmark, I think we've all gotten a really big network out of participating in EuRoC. We've gotten to know so many rocketeers from other universities in Europe and other teams, and we've had so many great discussions, and we can all learn from each other. So we only recently started building solid rockets, actually, which is really exciting. And we don't really know anything about them because we've been focusing so hard on the bi-liquid rockets. So we actually reached out to some other teams to ask them about their experiences with the solid rockets. And, some of them were laughing a little bit at us, like, you're DanSTAR, like you build bi-liquid rockets and you don't know how to build a solid rocket. And we're like, yeah, please help. So that's been really great. And I don't think we would have had that community if we hadn't known or if we hadn't participated in the EuRoC competition.
Are you in touch with the Copenhagen Suborbitals?
Yeah, we are actually, quite a lot. We geographically, we're located quite close to them. So, it's only like a short drive away. And also Jacob from Copenhagen Suborbitals, he's also part of the EuRoC organization. He's in our advisory board. So we keep a lot in touch with them. And fun fact, we actually beat them in Apogee Reached with our last rocket, Valkyrie. We got 45 meters higher than them with a bi-liquid rocket. So we have the world record for, university teams. And then we have the Danish record, which, feels equally good. I know 45 meters is not a lot, but Jacob informed us of the numbers. And we were quite excited about that.
Would you like to join the Open Launch Initiative?
Yeah, I think we actually did join the initiative. Me and Anton, another guy from our team, were present at the first meeting.
How do you promote your team?
We are present in every platform of social media except for TikTok. But yeah, we try to be very present. That's why we now have the marketing team again
Yeah.
to see if we are even more present. Yeah.
Was your team involved in the starting of EuRoC?
Yeah, we were actually. It's quite a funny story. So I'm going to tell it to you from the beginning. Okay, it's going to be a little long story, but I think you need all the details here because it's it was a journey. I mean, we all know what happened in 2020, right? But I think none of us on the team had any idea. I think probably most of the world had no idea what was in store for us. So in January, February, well, actually prior to 2020, we were supposed to launch Dragonfly, the rocket right behind me, the summer of 2019 at the Spaceport America Cup. And we realized in the spring of 2019 that we probably were not going to make it. It was just not going to be safe. You know, we needed to do a whole bunch of other tests and so on and so forth. So we postponed it. And we're like, okay, we're going to go in 2020 instead. This is going to be better. And then we reach January, February. We've heard about this, you know. For us, it's just like an illness spreading a little bit in China. A few people in Italy have, you know, been sick, but we have no idea. You were just like, oh, okay, well, it's not really going to reach Denmark. And, you know, we still got to go to the US in June. And then, you know, it just explodes from there. I mean, we all remember what happened, right? Just before everything shuts down in Denmark, Denmark locks down in the beginning of March. In the end of February, we had an event at DTU, at our university, with the launch of the ESA Business Incubation Center at our university, which was very exciting. If you don't know the ESA BIC, it's a startup accelerator, basically focusing on space-related startups. Very, very cool. We've advertised for them a couple times on our platforms because obviously we want more people interested in space in general. So that's really cool. And this event was at, you know, again, our university. And the then General Director for ESA was here, Jan Werner. And luck had it that there was a Q&A in the end of this event, this launch of the Business Incubation Center. And our then chairman asked Jan Werner if he would be willing to, you know, help, you know, student teams, volunteers in Europe, you know, get something started as well. At this point, the US competition was not yet canceled, but it would be in, you know, a short moment. But he was very open to the idea, and he was like, yeah, come talk to me after the event. So our chairman Rasmussen did, and got his phone number. Very nice. I got his contact information. And so then a few weeks later, when the competition was canceled, he called him and was like, yo, should we figure something out? Like we are a lot of teams in Europe that want to launch our rockets. You know, a lot of teams were planning on going to the US for this competition that is now canceled. Can we figure something out? He was very open to that. And a few other people from other university rocketry teams were involved as well and helped, you know, establish, you know, well, this competition in general. And then, you know, Portugal Space took on the challenge of coordinating this and did very well. As we can see, it's now the third installment of the challenge. And the rest is history. It was really nice, though, because at the first EuRoC competition, the president of Portugal Space actually thanked our then chairman Rasmus for, you know, his effort in getting this on the road, which I think was a really nice gesture.
What are your experiences at EuRoC?
Great experiences, I would say. Yeah, I mean, well,
It's going to be my first time.
Yeah. Sarah wasn't here last year,
Yeah.
but I've been at the first two EuRoC competitions, and it's been amazing. You know, last year we got a little award, the flight award. I mean, we were the only ones in our category, but still, it was important for us. And the first year we won the Team Spirit prize. So, you know, we actually last year we also made our own little trophy when we got back. I don't know if you can see because it's see-through, but we made this little trophy for ourselves. But yeah, it's been great. You know, it's a great launch opportunity. It's a great way to meet other, like I mentioned earlier, university rocketry teams. You know, we're very grateful to be able to establish that network and spar with other teams because of, you know, sometimes, you know, even though bi-liquid rockets get a reputation for being super advanced, like sometimes there are things we haven't thought about. You know, we all need a parachute in a rocket, and, you know, as we've seen previously, we've not been the best at that. So we can learn from other teams, you know, and it's a lot easier doing that in person. And last year, you know, we spent the whole day before the launch day helping the EuRoC organization preparing for the launch day, which was really nice. You know, got to see the launch site the day before, set up our own launch rail, help them with some practicalities. So I think we've had some really nice experiences there. And then after our launch day, we launched on the first day of the challenge last year. So we could take a little day off the day after, and we went into Lisbon, which was really nice. Also just like taking a day off, like pretending it's a holiday for 24 hours. That was really nice because it can be quite stressful building these rockets, and we don't really get a summer break when we do this. So really excited that there's an opportunity like this in Europe. Of course, Spaceport America Cup is the biggest international competition, and I think everyone wants to go there as well because that's also just a cool experience. But having something so close to home that is, easy to get to, we would need 3 flights to get to to Spaceport America Cup. And here, we drive the rocket from a truck with the rocket from Denmark to Portugal, and we just fly there. We can fly directly from Copenhagen, so it's super easy and convenient, and yeah.
Yeah, going to the US, it's a logistical nightmare.
Oh my God, yes. It's so much more expensive.
Yeah.
So it's been really nice. And Sarah is actually, from Portugal. So, having a semi-local, someone who speaks the language, I think is a big advantage too. Yeah.
How do you do your review process after the launch?
Oh, obviously, I don't know, you wouldn't know.
Yeah.
But you've seen the pictures.
Yeah,
right?
I've seen the pictures.
Yeah. So we're all gathered in like this big, tent-like thing. That's where the launch readiness review happens, and and then of course the post-flight review. I think that happened on the launch site last year. So we go recover the rocket right after the launch, and then when we come back with the rocket, then we talk about what happened here, what shouldn't have happened here, things like that. So I think there are more formal deadlines or more deliverables from EuRoC this year compared to last year, which is quite nice because it also forces us to start the documenting process way earlier. Because as you know, there's the concept report. Concept report, the technical questionnaire, of course, is the first thing, and then the concept report in May, and now pretty soon we have the design report, and then the technical report. So it's a good way of like getting into the habit of documenting a lot more, explaining a lot more about what we do, which has been our goal, at least from the very beginning of this project. Like, we need to document everything because, we're all students here, so we have an expiration date basically, and it's really important that we take into account that at some point the person who knows the most about this is not going to be on the team anymore, and this knowledge should be, at least to a certain degree, be available to the remaining members. And we haven't been too good at documenting everything previously. So we're trying to step up our game here. I think it was it Alice? One of the other teams. We should give them a big shout out at some point because we saw their report, and it was like 1,600 pages, and I was just like blown away. Like, this is so cool, guys. Like, they wrote books about what they do. So we've been pretty inspired by that, and we should give them credit where credit is due. Like, we were like, okay, we got to step up our own game. We need to document too. Because otherwise, at some point, all our great knowledge about pilot rockets is going to be, moved on in the world.
Would you like to join other rocket competitions?
Yes, absolutely.
We would really like to go to US next year.
Yeah,
like, we are thinking about it because right now we are working full on for EuRoC, but we want to start thinking about going to the US next year. So it's a goal for us.
Yeah, absolutely.
Yeah.
It would be cool to do both in 1 year with 2 separate projects. We have some hopes and dreams, of course, and it's hard to decide right now what the future holds for us. Even just 4 months from now, we don't even know where we're going to be, because a lot depends on the outcome of how the launch of Fornax goes.
Yes.
So, for example, this might be like hubris talking, because last year we were talking about like, what are we going to, because we're going to launch on the first day with Valkyrie last year. Then what are we going to do the last day? We can just launch it again. And then, when we found the rocket, we had issues with the recovery system. So the rocket had fallen from 6.5 kilometers without a parachute. And the first half, like almost a whole meter of the rocket was just polarized, obliterated. I think it had hit a tree on the way down, which helped a little bit. The tree was also destroyed. But that was so sad. So obviously, Valkyrie was never going to fly again. And a lot of good jokes, sad jokes, but good jokes were made about that, like, Valkyrie is in Valhalla now, and, you know, things like that. But so we won't make too many rash decisions just now. But I mean, before EuRoC was a thing, the goal that we had set was to participate in the American competition 3 times and, establish ourselves as, a really good collegiate rocketry team within bi-liquid rockets. So I think, the more competitions and the more launch experience we can get, the better. But maybe EuRoC will let us participate with like several projects next year, and we can just like line up all our rockets on like several launch rails and just like fire them one by one. That would be so cool.
A girl can dream.
A girl can dream. Yeah, we got to draft the email to EuRoC immediately. Yeah.
How much does your rocket cost to build?
Oh boy,
A lot.
a lot. Yeah. What is the price in euros? Can you do the conversion?
We have to do it very quick because
We
I
have to
don't
do
know.
it very quick. Yeah.
Um,
Okay, about 100,000 euros
yeah.
for our bi-liquid rockets, approximately. So yeah, but that's including the launch. Like that's including going to Europe, luckily.
Yeah.
So that's for the entire project. The rocket. So our first rocket, Dragonfly, was a little bit more expensive than that. That was about 130,000 euros. Because there was some preliminary, studies we had to make. We made a test stand, we made a demonstration engine, we made a second throatless engine before moving on to Gnome Child, the one that we're currently using. So yeah, it's quite expensive, but I think we could probably cut some costs, here and there. But we are also very it's very important for us that all our components, for example, if it needs to withstand a certain pressure, then we would prefer buying it in comparison to making it ourselves, because we have 300 bars in the system, which is quite a high pressure. So certain things we are not making ourselves, like our pressure regulator is very expensive, our propellant tank is very expensive, our engine is very expensive, and none of those are we gonna make ourselves, probably. At least not for this project, of course. I can't speak for the next projects.
Where do you get your money?
We do a lot of fundraising. You can actually see behind me here, if I move myself a little bit, you can see this is like a big bunch of our sponsors and partners. You can only see like half of them, actually. So a lot of our time is spent on, partnerships and fundraising in general, asking people, pretty please, we're very good students. We really want to build something very cool, and we would love to do it with your help and with you on board. So yeah, it's we don't pay. Usually we don't spend our own money. Lately that has happened quite a lot, unfortunately, because we had some other priorities than fundraising in the beginning of the year. We had a lot of other issues that we had to deal with. So fundraising was kind of down prioritized, and now we don't have any money at all. So a few of us had to spend our own savings, but hopefully we'll get them back when we up our fundraising game a little bit. We also get some money and support from our university. And for example, we test our engines on campus, and we have a really solid partnership with Campus Service at our university. So we don't pay for, the location of, we have basically a shipping container that we, put our test stand with our engine on inside. We have some videos on our YouTube channel of our hot fires of our engine tests that you can check out if you want to see. We don't pay for that, for example. So that's really nice. And they're also really interested in just, hearing updates about how it's going. So that's, amazing. And, we're sitting in DTU Skylab right now, which is the innovation hub of DTU. And, we don't pay rent for staying in the garage here. So that's also really, really nice. And we get a lot of support from the workshop here in Skylab. They help us so much. In comparison to if we would have to go somewhere and, pay for that extra manpower, there will be a whole other cost structure. So I think that's also one of the reasons why we're able to keep the cost like relatively low in comparison to, it is a bi-liquid rocket. It is an expensive project, but the fact that we get so much support from, not like monetary support necessarily, but just, in terms of manpower or help with components or similar things, that's very important for us.
How do you build your rockets?
I don't think we have time to go through how you build a rocket. It's SRAD rockets, student research and developed. it takes quite a long time to describe. But we basically try to do as much work, design and building ourselves as we can. We built the flight computer, designed and built that ourselves. So soldering all the boards, for example. We designed the engine. We don't 3D print the engine ourselves, but the Danish Technological Institute 3D prints the engine for us. But we designed it, and we have a lot of like things where we design something and then we pay someone to manufacture it, basically. The same with the carbon fiber panels that we use. We currently don't have the competencies in the team to make these panels. We're working on that. Hopefully we'll get some new recruits that are interested in working with carbon fiber. So we design basically how they're supposed to look, and then we are in touch with the company about them manufacturing it for us. And then usually we're requesting either a student discount or a partnership or something similar. And sometimes that doesn't work out, and then we just end up having to pay like everyone else, basically.
What software do you use to design the engine?
The software that we use on the mechanical team is all like CAD programs. So AutoCAD, SolidWorks, programs like this. Any CAD program can work, basically.
And for the simulations, we used
OpenRocket. Yeah, that's true. Yeah. For the flight simulations and for designing the fins and the flight path and the theoretical apogee, we use OpenRocket. I think it's also suggested by EuRoC now. Yeah. Maybe it always was. We use OpenRocket for that, which is built specifically for rockets. So it's pretty great. Yeah, and then mostly every other software that we use is written by ourselves. Well, you guys.
Yeah.
So we develop all the software ourselves as well.
Everything that we do for controlling the rocket, it's all coded by us. It's nothing that we use from another kind of program. Everything is hard coded by us, which can be a pain, but I think it's also nice when it works and you feel like, okay, this is my hours that I did not sleep in here. So it's nice. It's very nice.
And you use C++?
Yeah, we use C++.
Yeah. So that's also hardcore, but pretty beneficial on the other side of studying, because it's my impression that a lot of the industry uses C++ as well.
Yeah.
So we've been asked a couple of times why don't just use Python or something? No.
What fuel and oxidizer do you use?
So we use IPA, isopropyl alcohol, as our fuel, and we use nitrous oxide laughing gas as our oxidizer. We've chosen that mainly because it's cheap and readily available and quite easy to work with compared to, say, liquid oxygen, which is quite hard to deal with. It boils off very quickly, and it's also quite hard to get permission to use it in Denmark. I don't think we would be able to switch our oxidizer right now if we wanted to. We have thought about changing it, for example, designing the next engine to be used with liquid oxygen, or even other types, just for the fun of it, to learn some more about other types of propellants. Because also at this point we've established ourselves as an organization and a serious team, which is really nice. But that'll be for the next team or the next project to decide if we will change those. But for example, laughing gas is super easy to store, which is super nice. So when we've had our hot fire periods, we can just leave the bottles next to the site where we test our engines and come back and use them next time we need them, whereas that wouldn't be as easy with liquid oxygen. There was actually a fun situation once where I don't know if you're aware of this, but at least in Denmark, some young people use laughing gas as what's it called, basically like a drug. So they will inhale small capsules of laughing gas, and when we have our hot fire tests, so our engine tests, we show up at 7 a.m. on the test site and get everything ready. It takes a few hours to get everything up and running. So in order to have time enough to actually test the engine a couple of times during the day, we need to meet really early. And we show up this Saturday morning or Sunday morning really early at 7 a.m. We go down to the container where we set up the engine and everything. And our laughing gas bottles are stored. These are like, the huge gas bottles, right? Like, you know which bottles I'm talking about, right? Yeah. And next to these bottles, there's like a really suspicious plastic bag. And we're like, oh no, what is this? And then, we take a look in this little plastic bag, and there's like a bunch of these laughing gas capsules. So some young kids had been sitting there like the Friday night, inhaling laughing gas, not knowing that there was like 150 liters right behind them the whole time.
If they knew.
If they only knew, yeah.
You plan to use frost vectoring?
No. So we're not going to use any Airbrakes either. We're participating in the 9-kilometer category, and we do not expect to go above 9 kilometer. If we do, I'm not going to be mad, not at all. But I don't think that's possible. We're not planning on using any Airbrakes because we're participating in the 9-kilometer category. And if we reach 9 kilometers, that's completely fine. Like, we're not going to try and stop ourselves from going to 9 kilometers. But, we reached 6.5 kilometers last year, which was the highest a student team had gone with a bi-liquid rocket, at least with the, telemetry, like pretty, what's it called, precise telemetry measuring. So 9 kilometers is quite a jump from that, at least for us. So no Airbrakes for us. And we're not going to be moving the fins either, because I'm fairly certain that that's illegal, at least until 6 kilometers is reached. So we'd have 500 meters, at least compared to last year's launch of moving the fins. So, in terms of, the stability and making sure that the rocket is vertical during the flight, we focus a little bit more on the launch rail. Yeah.
We have a bigger launch rail this year.
Yes.
Yeah. So, to increase the stability when the rocket leaves the launch rail.
Yeah. It'll be 3 meters longer this year, which will be exciting. We actually have you can kind of see it. We have these postcards from our launch last year. I don't know if you can see it on this picture. Well, you can kind of see it. The rocket, like, it's not even straight anymore. And that's, very soon in the flight that it is no longer like flying straight. So we want the passive stability to be increased a little bit. So we'll go higher. One of our team members last year calculated, or at least made an estimate, that we had probably lost about 1 kilometer because of the launch rail not being taller. So this time it'll be taller.
What kind of fins do you use?
You can kind of see them on Dragonfly, actually. I don't know if it's too small for this little video here. Previously, we've used aluminum and steel. Hopefully this year. It's not really settled yet, but we're hoping to be using carbon fiber fins with like an airfoil, so they're more aerodynamic and also lighter. Fingers crossed that will work out. That would be really exciting, and would be really cool to do something different. Learn another type of fin than last year's rockets. Yeah, we actually repurposed the fins of Valkyrie.
Yes,
for our new solid rocket, because it's going to be smaller. So we cut up the Valkyrie fins. So reusability, yes. So those fins are being repurposed and are now being used on the solid rocket that we're building, which is really nice. I feel like it's,
environmental.
Yeah, and it's nice that, something from Valkyrie, because Valkyrie, as I mentioned earlier, hit the ground really hard, and not much was left to be reused on Valkyrie. So for something to be able to be reused on another rocket, means a lot to us. We are reusing the propellant tank from Valkyrie. It is a common bulkhead stainless steel tank, so it's a tough one. So we had the end caps fixed, swapped out with new end caps. So it'll be slightly smaller, but it'll be fine. We'll bring a little less fuel compared to last year, but it's definitely worth it being able to reuse something that is, quite expensive. And also,
did you develop your own PCBs?
Yes, that's we showed before that we do everything ourselves from the PCB side. Electronics, it's all made by us. It's all researched by us. So yes, it's very cool.
Quite proud of it.
Yeah. This year's we're gonna have green ones. No.
Black ones.
Black ones. We talked first to be purple.
Yeah. They were way more expensive.
They were way more expensive.
The color scheme for Fornex is purple and yellow.
Yeah.
I don't know if you've seen the color schemes or the mission patches for our previous rockets, but they're blue and red. So, what you get when you mix blue and red, you get purple, because Fornex is, the third iteration of the Dragonfly and Valkyrie project. So we thought we needed some we put a lot of symbolism
on
into
our
our
patches.
designs and the mission patches and the graphical design part. It's it's not something that makes us go higher or faster or anything, but it is something that really increases the morale of the team. Like, people love having a nice mission patch and a cool name, and I think it's important. I'm not sure everyone agrees, but
I agree.
Yeah, we agree. We think it's really important, and it's always exciting when we meet someone who is equally excited as us about something like this. So, sorry, you were talking about the electronics. This was a sidetrack.
Yeah, but basically it's that, the electronics is all made by us and researched by us.
How do you transfer data from the rocket to a ground station?
Last year we had basically a cable, and this year we are still testing to have it wireless. So it will be very nice. Like, we had a test and it worked, but we still are on the testing phase. But this year we are trying to go wireless.
Yeah,
for the data transfer. It's very exciting. Not to have a long cable. Yeah.
Because it's 700 and something meters.
Yeah.
The cable from the launch pad to mission control.
How do you make your launch rail?
We actually designed our launch rail ourselves quite a few years ago. I think we gave the design to EuRoC as well. So I think they've been a little inspired by our design, or at least maybe used it when they designed their own that they used last year, which was really nice. We felt recognized. We had a guy making the whole launch rail a few years ago. That was really cool. The launch rail was ready even before half the rocket was ready. The Dragonfly rocket, of course. So it's quite a simple structure. We sometimes joke that this is not rocket science. Like, this is the part of the project that's not rocket science. So I think a lot of other teams have, at least American teams, we've gotten some inspiration from when designing ours. It's made up of aluminum beams, like the tower itself, basically, and quite some heavy legs and a heavy core. So that we will put some extra weight on, because the legs are not quite long enough to the dimensions of the rockets that we're building right now. So we need a little extra weight to keep it down. And then pretty standard Bosch profiles to attach the rocket to the tower itself. Like you said earlier, it's going to be 3 meters taller this year than last year. It's going to be really nice in terms of the passive stability, and then that's the primary function. But also, it's just going to look really cool. It's going to be really cool. We were looking into, one of our procrastination tasks was looking into putting LED lights on the launch rail. So at night it would light up. That would be really cool.
That would be very cool.
Yeah, we're still looking into that. Maybe someday when people have nothing else to do or tired of all their technical tasks, they will be given a task that, figure out a way to put LEDs in the DanSTAR blue, of course, on the launch rail. We should probably check with the military, the Portuguese military, if we're even allowed to put lights on the launch rail. But otherwise, we can put the lights on, at least here in Denmark, when we're testing it and using it for our own tests back home.
So nice. That would be so nice.
So nice.
How did you design your recovery system?
The recovery system, it's always, a sore spot for us.
Yes.
We had issues both in 2020 and in 2021. Hopefully, no issues in 2022. Guys, let's pray, knock on wood, salt over the shoulder, all that stuff. Yeah. We're working really hard on improving the mistakes of previous recovery systems. We're planning on making a whole new recovery system this year and testing it on the small solid rocket that we were building. But, as always, time is critical. And we ended up deciding that instead of making a whole new recovery system that we would probably have to reiterate a couple of times, we still want to do that, but just do that as a separate project, and then just optimize everything we can on the current or previous recovery system. So the tests that we have done on the recovery system previously, we did the same tests last year as we did the year before that. So for both the Dragonfly and the Valkyrie projects, we did the same tests, essentially. And we're going to add a whole bunch of extra tests to that. So we do a lot of component testing, and testing that this little thing works, testing that the CO2 cartridge can shoot off the nose cone when it should. And we test that the parachute can unfold when thrown out from a building, basically. but we want to test a few more of the components together this year. But yeah, we were considering changing it to, a pyrotechnic the cartridge system instead of the CO2 cartridges, so then using black powder. But it's been quite difficult to get permissions in Denmark to use black powder because we have pretty strict rules on that. So we're still working on it, but it's just a little more complicated affair than we initially thought, or at least a more time-consuming affair.
Do you play Kerbal Space Program?
I wish we had the time, man.
Maybe after launch?
Maybe after the launch, yeah. Maybe we can, instead of going to Lisbon this year at the
Yes.
at the competition, we can just all sit and play Kerbal Space Program instead. No, it's a really fun game. It really is. It's very addictive. I gotta say, it is more fun launching rockets in real life than in this game. But yeah, I think it's a good start, and I think it has the option of encouraging kids and young people to pursue an education or at least hobbies within space or rocketry related studies. So it's a really fun game, but man, we barely have time. We barely have free time these days. Our free time is building rockets.
Yeah.
So I used to play a lot of RuneScape instead. Not really any rockets there. RuneScape. You know RuneScape?
It's the one where he's the guy running.
And you can go fishing. Do you know RuneScape? Oh man, it's a banger game. It is so good. We used to have LAN parties just playing RuneScape. I'll introduce you after the
LAN
launch.
parties?
Mhm.
This is old.
I am old, okay?
LAN parties?
Don't judge me.
What are LAN parties?
You see?
What is your problem? Is that what they're called? Do you call them something else these
No,
days?
the LAN parties is when everybody was hooked on the internet by cable.
Okay.
Yeah, those are the real LAN parties.
Right. I thought they were still called LAN parties, even though
It's not LAN anymore.
Then what'd you call it? Just
Game
parties?
parties?
It's just a party.
Yeah, it's just a party.
Okay. Well, I am also from the age where it was LAN parties. I gotta admit, I am older than I look.
What payload do you have in your rockets?
Like last year's, we had little Legos. Yeah, but this year we have
find them.
a partnership. It's a partnership with DTU. So we can have a CubeSat from them. So we're gonna launch. So this time it's not just a dummy mass. It actually has a purpose, which is very, very nice. Yeah, use.
Yeah, I just found the picture from our payload from last year.
Yeah.
We had little Lego astronauts. Can you see it?
Yes.
Yeah, they were in trouble.
Yeah.
But the Valkyrie brought them to Valhalla. Yeah,
Yes.
but we've been asking Lego for a sponsorship of little Lego astronauts.
Yes.
It would be really cool because Lego is Danish, as you know. So it's we're all big fans of Lego. In 2020, we actually asked them for a little red Lego car because that was right after that Elon Musk or SpaceX had launched the red Tesla into space. So we wanted to be like, we can launch cars into space too. Obviously, we're not going to reach space just yet, but it would have been a fun joke to have a little Lego car on the rocket. Maybe we have room this year. We'll see.
We'll see. Yeah.
But yeah, it's a really nice collaboration with DTU. Yeah, DTU Space.
Yes.
Yeah. So it's actually the first iteration of a CubeSat that they will eventually launch to space, which is very exciting for us to be a part of that in general.
Do you have any announcements or dreams?
I mean, we always have many, many dreams. These days, we dream of a beach holiday or just seeing our families for once.
Yeah.
As you can tell, and as we've talked about a couple of times over the past few weeks or months, even because I think we've been in touch since maybe February or something. That we are quite busy. It is really a struggle building such an advanced rocket, and especially because we do try to make as much of it as we can ourselves. So we dream about having more free time at some point. Like I mentioned in the beginning, we all dream about going to space at some point, but I think we have some more attainable dreams before then. We dream about a successful EuRoC, maybe even claiming the prize, the liquid 9-kilometer prize again this year. That would be really nice.
Yeah.
Maybe the Team Spirit Award, that was really great. Maybe even the overall prize. We're dreaming big now. Just generally, that would be really cool. We're obviously also dreaming about beating our own world record. I do know that the portal space from Norway is going to compete in the same category as us, which is really exciting. We're really excited about finally, getting some basically colleagues, I think we should call it, within this field. That's going to be really cool. I'm sure we can learn so much from each other. So it's really exciting.
What are your personal plans for the future?
So you already have a startup, right?
I have an idea for a startup. But, when you are building a rocket like this, you don't have a lot of time. So I want to build my startup after the launch, maybe. Mm-hmm. I mean, until then, it's very, very hard to have a time after this. So, yeah, my plan is to start a startup. It's not on rocketry, but
I'm just waiting for NASA to call me, to be honest. Like any day now, any day.
Any day the phone will ring. Amalie, we need you.
We need you, Amalie.
We need you.
You got to go to space right now. No, I think, it's easy to plan or have dreams.
Yeah.
But actually executing on it is a whole different story.
Yeah.
And I'm graduating this fall with a master's degree, and a lot of people have asked me, so have you started applying for jobs, or like, where are you going to go? I'm like, I'm going to try and get 8 hours of sleep continuously, 3 meals a day, maybe for like a whole week, try that out and see how that feels. I'm going to catch up on a bunch of series. Like, I haven't watched series for like 2 years, 3 years now. And I want to see what the hype is all about, Stranger Things, Westworld, all these
Very
series.
nice.
I haven't watched anything. I feel old and I feel behind, No, I think, a lot of us in the team would love to work with something space related.
Yes.
We do have some team members that, to be frank, don't really give a hoot about space or rockets, but they are in DanSTAR because here they get to work on something super advanced that they wouldn't have the option to do otherwise. Like we spoke about in the beginning, we have no space or aerospace study line at our university. So people come here for, that kind of things too. But I think, with ESA growing and, the space industry in Europe growing in general, I'm sure there are going to be so many opportunities for us to find, something to do within this field, either, through the industry as it is now or making our own startup. Maybe a little launcher company would be cool.
Do you have any advice for young rocketeers?
We talked about this just before this interview, actually, because obviously we can talk for hours and hours about what to do and definitely what not to do. And we kind of settled on, being brutally honest, basically, because this is a really tough field. Like, it's going to be so hard. Like, life is really hard when you want to build advanced rockets and you want to launch them too within a very short time frame. But it's all going to be worth it. That's all we want to say, even though, it takes 40 seconds for this rocket to complete its trajectory. Those are the best 40 seconds of your life. Like, I have lived for 30 years now, and that minute was the best minute of my entire life. Last year when we launched Valkyrie, it is so worth it. You, for a brief moment, you forget all the all-nighters you pulled, all the early mornings and late nights and test days, test weekends, test weeks, all the hard work and all the sacrifice, all the family birthdays, family holidays, university hand-ins, all these things that are important in your life in general, and you sacrifice those to build rockets and to do what you are most passionate about. It's worth it.
I mean, I'm very excited to feel that.
Yeah.
Yeah, because I only felt that through the videos, and you can actually feel everybody so happy. Yeah. So happy. Yeah.
What are your favorite space movies?
We agree on this.
Yeah,
actually.
we agree on this.
We have the same favorites.
Yeah. So obviously, top one is Interstellar, followed very, very, very closely by Hidden Figures.
Yeah.
So nice.
Very tight race because both movies are,
Yeah.
We obviously, The Martian is a great movie as well. It's hilarious. The book is great too. Definitely recommend that. We have a list of the worst space movies too, if you want to hear. Gravity is the absolute worst. They did Sandra Bullock so dirty on this movie.
No.
Like, she's an incredible actress, and they did her dirty. It was an awful movie.
Yes.
And we went on a field trip recently in DanSTAR to the movies to watch Moonfall. Have you heard of it? Did you watch it?
Yes.
What did you think?
It wasn't that realistic, let's say.
No. The moon was out, of course. We watched. So I was in the movies a few weeks prior to the whole team going, I think I was watching some Marvel movie, and this was one of the trailers, and I was just like, sitting there, like I grabbed my friend, I was like, what is happening? You know, like the moon is out of course. The moon is a mega structure. Oh my god, it was a mess from beginning to end, and just, you know, halfway through, like the plot line just kind of shifted. Like it was wild. It was wild. Like we were having a party basically in the movies. There were not many other people than us in the theater, and I think they were so annoyed with us because we could not control our laughing. You know, it was so unrealistic, and it was just, oh my god. Yeah, I mean, it was entertaining, I gotta say, but for a space movie, it was the worst.
No.
It's
a no.
No.
Immediately no.
Immediately no. I've seen what I needed to see.
Do you have any questions for me?
When do we get to see a rocket that you build?
I don't know. It depends what rocket.
Okay. I mean, there's quite a few rocketry teams in Italy, right?
I think there's one.
I think there's both Skyward, and then there's another one as well. Anyway, we'll be excited to see you launch rockets in the future. Otherwise, you know, you're always welcome at DTU. We can save a spot for you in DanSTAR when time comes. We do have some Italians on the team, actually. Yeah. So, do you have any other questions, just for like rockets or life in general? You know, we can answer anything.
So you use isopropyl alcohol as your fuel, right?
So basically hand sanitizer.
Yeah, why didn't you choose methanol, ethanol?
Because again, IPA is quite easily available and quite cheap, and it's easy to store, easy to use, and then, you know, the combination of IPA and nitrous oxide is quite optimal for us. If we're changing our fuel, we'll have to change, you know, the engine as well, which obviously we will for hopefully the next project, but it'll be a bigger change. We focused on some other changes this year and reusing the engine. You know, feel free to reach out. We do try to reply quicker than we have in the past.
Yeah.
But like I said, it's we're actually on our summer break from university right now. Like our courses and exams have finished, but that usually means more time for DanSTAR. I'm not even finished with my studies. I'm writing my thesis right now, so I'm not even on summer break. But yeah, so the summer break at our university usually means DanSTAR time, most productive time of the year.
Yep.
Except for maybe like the 3 weeks leading up to EuRoC. Oh my God, we're here day and night. Once we were here so early in the morning that when the staff at DTU Skylab showed up, they were like, "Oh, did you sleep here?" Like, no, I just look like this. This is just my face now. Like people have commented so often, like, "Oh, you guys look tired." You think? Like this is just how we look now. Can't help it. But I think the sun and the vitamin D in Portugal will help us. You know, when we get to that stage. Of that. Unfortunately, not unfortunately, but you know, coincidentally, the launch site is covered with like a very thick layer of like dust, sand. So when you get back from the launch or the launch pad, you're like, "Oh my God, I got so tan," and then you go in the shower and you're like, "Oh, it was just dirt." That's really sad. But I guess it's nature's sunblock.
Yeah.
So you don't get sunburned because you're just covered in dust. I mean, we could talk for hours about this. You know, like I said to you when we were messaging, you know, we can usually talk for more than an hour and a half or even 2 hours.
I mean, I think you can talk at least half an hour just about the mission patch. So.
Oh my God, yes. I'm almost happy that you didn't ask us about our mission patches or like the general design, because we would have spent another 20 minutes on that. Like we care a lot about, like I mentioned earlier, the graphical design and the symbolism and everything that we do. Yeah, we were at a conference recently. We've actually been at 2 conferences this year, which is really nice. I was at the Space Propulsion Conference in Portugal back in May, and then we were at the Space Festival, Summer Space Festival. Yeah, sorry, in Brussels. I think 3 weeks ago.
3 weeks ago.
Yeah, which was really nice. We had a workshop on designing engines. Yeah. Which was really, really educational, I think. And we met a guy there at the Summer Space Festival in Brussels who was equally excited about our mission patches as we were. And I think we talked for like half an hour about them. It was the best day.
Yeah, it was very nice.
I felt so seen. I felt validated. Yeah, I know, it was great. His job is marketing in the space industry. So he really appreciated how much thought and effort we put into our marketing in general. So yeah. It was really nice.
So shall we end?
I mean, again, we can talk for hours about this, but if you have no further questions or things you want to ask or know about, then we can do a part 2 at some point. after the launch of Fornex, we can do a part 2 where we can go through everything that we didn't mention in this interview.
Okay, well then, bye.
Yeah, thank you for the invitation.
Yeah.
Enjoy your weekend.
You're welcome.
Bye.
Bye-bye.